Hey guys, so we're doing our notes here today virtually, or I'm doing them virtually, so hopefully you guys are able to follow along. This works out okay. I will be back on Tuesday, and I ask that you guys bring your homework that is due today, and then the one I'm giving you guys today that's due Tuesday as well. So you'll be checking 2 homework assignments when I get back. So what we're talking about today is really similar to something we talked about in geometry. So I'm hoping this isn't too different from that. I know geometry was a couple years ago, but hopefully it kind of comes back to you a little bit. If-then statements we talked about back in geometry. And so an if-then statement, for example, is, if I, so if I didn't come to school today, I needed to have a subplan. So if I didn't do something, then I had to do this instead. So an if-then statement is exactly what it sounds like. So if P, then Q. We use those P's and Q's all the time. And so they can also say P implies Q. So basically P is like causing something to happen with Q. So we say it implies. The hypothesis, or the antecedent, is the first part of that. So that's the P value in this. So it's the if part of the statement. So that's the first half. The conclusion is the second half, which is our Q. And that's going to be the then part of the statement. Consequent they use as well. So we're going to do a truth table to kind of show how this works, and I'll kind of use this example to help me. So if it is a monkey, then it has a tail. We're going to say, for the most part, if we find a monkey like out in the wild, he's going to have a tail. I know there could be an outside weird situation where the monkey lost his tail in some tragic tail accident, but we're going to assume that the monkey still has his tail. So if it is a monkey, then it has a tail. That's where the statement we're going to kind of use to help us with this. I'll kind of bring that up here in a second. So when we do this, I'm going to make a chart. So I'm going to have P, I'm going to have Q, and then I'm going to have P implies Q. Okay. So if it's a monkey, then it has a tail. So this is true. If we find a monkey in the wild, it should have a tail. That means it's going to have a tail, so that's going to be a true statement. Then, if we find, so if you have it where it's a true statement to begin with, so if it's a monkey and then we find one without a tail, that's false. That means this statement's not a true statement. That's a false statement. So maybe you would kind of conclude that at this point. You're saying, well, there could be tragic monkey accidents without tails. So that would make this statement false. Now, there's a chance that I encounter not a monkey. So I go out in the wild, or I go home to my house and I encounter an animal. It happens to be not a monkey, it's a dog, but it has a tail. So it's possible, if it has a monkey, then it has a tail. That second part could be true. But it's still not saying that this is a false statement. So this is still a true statement. So the fact that I'm saying if it has a monkey, then it has a tail, I go home and I'm like, oh, I have a dog, that doesn't prove the statement is false. But also, there could be this circumstance where I run into an animal, or even I could run into anything. I could run into a car. I could see a car, and then it doesn't have a tail, so that's also false. This is still a true statement. That hasn't made this statement false. So just understanding that only thing that can disprove this statement is if this first thing's true and the second one is false. So again, if you go find that sad monkey without his tail, that would be a false statement then. All right, so we're going to talk about negations of these if-then statements. So to negate an if-then statement, so we have if P then Q, the negation is P and not Q. So one of the things I want to be careful about, it's not another conditional statement. So do not make another conditional statement. So if I'm trying to negate it, if it's a monkey, then it has a tail, I don't want to have another if-then statement. So this should not be an if-then statement. Sorry, my E got lost there. So we're talking about the monkey and tail. So the monkey and the tail, it is a monkey. And it does not have a tail. So that would be the negation of the monkey statement. So the if-then is not part of it. So here's our if-then statement. If Tim's a Packers fan, then he loves the Bears. You might agree that that's not a true statement to begin with. That's okay. Don't let that throw you off. The negation of this is Tim is a Packers fan, so we take the if out of this. And so again, take the then out of there. He does not love the Bears. Probably a more valid statement if we had to be picky about that. All right, so converse, inverse, contrapositive. These are all rules we talked about in geometry. So hopefully they don't seem too crazy, too different. So the converse is going to flip the if-then parts. So converse, so this is P implies Q. The converse is going to be Q implies P. So if it's a monkey, then it has a tail. So the converse of this would be flip that. So if it has a tail, then it is a monkey. That's the converse of it. The inverse, which I think I always get mixed up with the negation, the inverse is basically saying not of each of the original. So it's taking the P and Q and you're going to doing not P implies not Q. So you don't change the order of the original, you just make them not. If it is not a monkey, then it does not have a tail. Now I'm hoping you're realizing and starting to think about these. If it has a tail, then it's a monkey. So again, I go home, I see my dog, he's got a tail, or she's got a tail, she's not a monkey. So these are false statements. And they're both false, and that's okay. They should always be, actually these two should always be the same. Now the contrapositive takes both of these and mushes them together. So it makes them both nots and it flips the order. So let me show you guys that one. So it's not Q implies not P. And again, we always go back to the original. So starting with the tail. So if it's not a tail, it does not have a tail. Then it is not a monkey. So, I go outside, I see a tree, it does not have a tail, then it is not a monkey. That's a true statement. So if I encounter some animal in the woods, it doesn't have a tail, I can assume it's not a monkey. So typically this one is true if the original is true. So the contrapositive and the original have the same truth table. All right, so the last thing I believe we're going to talk about. Last thing we're going to talk about is biconditional statements. And again, I remember teaching this in geometry, and we were horrible at it. I'll tell you that. It's probably the most often missed question on my test. Biconditional is basically if both the original statement and the inverse are true, we can write what we call a biconditional. So it replaces the if-then with if and only if. So we replace if-then with if and only if. Now this only works if the if the original statement and the inverse are true. So both the original and the inverse must be true. So the original statement, if two angles are complementary, go back to geometry, complementary angles, that means they add to 90 degrees. That's a true statement. Now if I flip that, the inverse, it switch the if-then parts. So with that, it's if two angles add to 90, then the angles are complementary. I'm going to shorten it up a little bit. We're not going to fit it. So if two angles add to 90, then they're complementary. Both of these statements are true. So in that case, rather than saying both of those things, what we do is we basically take the hypothesis and the conclusion and put if and only if in the middle. So I'm going to take the P, so it's going to be P if and only if Q. So I'm not having if and then, I'm having the if and only if in the middle. So two angles are complementary. If and only if so then the second half of that statement is the angles add to 90 degrees. Like I said, this was always a tough question on like a test or a quiz for geometry. For whatever reason, they were confused about the idea. So this is the only case when both the original and the inverse are true. So we couldn't do this with the monkey problem. It basically means that the P and Q go both ways. So it goes back and forth. All right, so that is it for today. So hopefully you guys can take those notes, And then the homework is listed here. I'm hoping it goes okay. And then again, make sure you have last time's finished as well to show me on Tuesday. Thank you so much. Have a good weekend.